This is assignment 01 to the Get to Know Your Tools for the Arduino Starter Kit.
The materials needed for this experiment in particular will be using some electrical components, such as the resistors here. These two wires here that connect the Arduino Uno to the breadboard and the Arduino Uno itself, an LED light, any kind, could be yellow, blue, or brown, or red. Some breadboard jumper wires. In this case, we have two of them that we need. But for stuff like parallel and series, we're going to need more, which we'll get to later. And of course, a button to connect it. And as well, the USB cable to connect to the power source to be able to do this. So before building this, the first thing you must make sure is the USB cable is disconnected, just as a precaution, so you don't get to shock yourself when the voltage comes in. So what we need to do is get our two wires here. The red wire, you're supposed to connect it to the 5V and the positive sign. This is for power. And for the black wire, you put in the area that says GND, right here where it's highlighted there, and put it in the negative sign, or the ground area. Then after you place the wires, which connects to the main power source, our Arduino Uno, which with the USB cable is connected to my computer, you could place down the switch anywhere you want, as long as it is connected to the breadboard here, so that the power can still flow through it. And then after you do that, you can place in the LED light wherever, as long as it's close enough to the button here. Then the jumper wires, make sure one of them is connects one side of the LED light to here, to the power button, and the other jumper resistor connects to the negative side of the breadboard here. And then afterwards, you get a 220 ohm resistor and put it on the positive side, so that both these can flow through and get to the LED light. Now, the point of the resistor is to absorb some of the electrical energy that's going through here, so that there won't be too much voltage that goes to the LED light after all. And so the resistor absorbs some of the light, absorbs some of the energy. Either in a 4 stripes here, or 5 stripes, essentially. If you can find one that's at least similar to 220, it's fine, and no matter the stripe. For example, the one that we have here has 2 reds, 2 blacks, and a thin brown stripe. Essentially, the 2 reds become 2s, so it will essentially be 2, and then 200, and 222, and then the first black will become a 0, the 220. The 4, and then the other black is essentially times 1's resistance, so that'll become 220 ohms resistance essentially. And the final brown color, the thin one, is essentially plus or minus 1%. That's what it means. So the final ending strips are percent differences, while the 4th stripe can be black, brown, red. It just is multiplying by either 1 ohm, 10 ohms, 100 ohms, 1000 ohms. It depends on the color. After you do the setup properly, you can then finally plug in the USB cable in, and then all you need to do now is just press the button and the LED line will turn on. And make sure it's in this specific setup, because otherwise it will either not turn on, or if you have a different resistor, the light will be either dimmer or brighter, depends. Essentially what the switch is doing is interrupting the electricity flow. Every time it's off, or it's not being pushed on, the electricity flow will not reach the LED light. Every time you do push it though, it's going into the LED light and turning it on essentially. So what we did earlier was a simple circuit. Now this is a series circuit. Essentially now we have 2 buttons, an additional jumper unit, but still having the same ohm resistance, and still now we have 3 of these breadboard jumping wires. Essentially we have to have 2 jumping wires that are the same. Make sure they're not different in color, otherwise it will not turn on. Essentially now the difference is if you click one button, it won't turn on, or the other still won't turn on. So the only one to turn it on is with both buttons, so that the electricity flow is full and complete and just goes into the LED. The resistance is still the same, because I'm still using the same resistor, though you could change it up to have a different, either make it brighter with a lower resistance or make it dimmer with a higher resistance. That's how it works. Okay, now after we did the series circuit, this is a parallel circuit. And as you can see, I decided to change some jumper wires since the ones I were using were too small to fit into it properly as according to the book. So I have 4 jumper wires. Now, 3 of them being the same, while 1 of them being different. 1 of them still connected to the negative side, while the rest are connected here. The difference between parallel and series is this. You can just press 1 button and it will still turn on. Same thing goes for the other. You press both, it will also still turn on completely. So with the parallel circuit, the electricity flow can be, how do you say this? Able to flow better, you could say, than a series. Because if one thing is missing, then it will just stop working. However, in a parallel, if say one of these disappears, then it will just simply become a series circuit, and you could still just press both buttons. Or you could just press 1 button no matter what, and it will still work. Also, we're still using the same resistance here. And that's pretty much it for this assignment. So we covered a simple circuit, then a series circuit, and then finally here the parallel circuit. Thank you for watching.